Everybody's ready? Okay. So today our topic is compact motion, but before we have several stuff to discuss about, because some Kirill asked me about workload, after Daniel asked me about absolute relative motion, but today actually it wasn't the lecture. It should be in the end. He had time to do this?
Yeah.
Okay. So about workload, because so we have a lot of home tasks and so on. I'd like to ask you firstly, why do you think I gave you so much home tasks? What's of my goal to do? Do you think that I love to check it, to sit and spend time to do this? What do you think?
Yes, for us to get some practice.
Yeah, I think motivation is clear for us.
Okay. So from my side, that I want to give you quite broad knowledge in this, and you need to dive to in. Is the reason. You said that you have home task. As you know that the trainer's responsibility to, so you need to trust me, and I give you such knowledge that help you in future. And for this purpose, I ask our previous batch who studied on using this exactly home tasks, and they give me a feedback. So there are two feedbacks. I mean, this is Daniil Burakov, so you can read it in English. Actually, we have one Hennis one, so you can read.
Well, it's in Russian.
What again?
It's in Russian.
Yes.
I mean,
Yeah, because, but okay, roughly speaking, so all of them did it in GeoGebra, and one of them told that, yes, I spent about at least 3 hours, so where did you use it in future? I mean, at least in next course, mechanism machines, and also intro to robotics. You will have it the next semester. So, and he said that if you want to become a real robotist who works with control theory and so on, you have to do this. Ask feedback from Yarek. He is more informal, so he said that it's holy crap that he did it whole week in the beginning, but after this that he spent each evening in the first 3 home tasks, and after this it became much more. I mean, he became to do it faster. And I asked him, is it helpful for you? Yes. He said that it was painful, but it's helpful really. And Hennis? So again, I spent a lot of time, except static because it is easy for him. So helpful kinematics. He had actually, yes, I had to change some stuff in the dynamics. It was too brief, but he said that kinematics was very useful. He used it in fundamental of robotics, machine learning, robotic systems, in robotics track. And he said that it was good to visualize. So, as you may see, previous batch who passed all of this stuff, he said yes, it was hard. And actually, you in robotics, almost everybody aware you that it's one of the hardest track. Why it happened? Because when you're studying in programming, actually you have a quite good background, and you just continue to increase it. When you go from to robotics, in this case, you have a lack of knowledge, actually. Because when I studied in Bauman City University, as an engineer, I have physics on the first semester, second semester, I have some engineering stuff on first, second semester, first year, and second year too. And on the third year, so we start to learn some advanced stuff. We have to squeeze it and put it to you. I agree that it's very hard to do all this stuff, because you didn't make simulations before. Am I right?
Yeah.
That you need to learn how to do it. So you will face this problem that you cannot solve it analytically. You have to solve it numerically. Some cases, yes, it exists, because it's just a common task like this. But in the end, if you survive, you become much more, let's say, prepared to your future life if you want to become robotics. What can you do? Actually, does anybody try to do it together except both of you? Probably. Did you Actually, I expected the individual report, but who said that you cannot solve it together? You can see, divide in some groups and try to derive equations, think how to solve it. You try to solve by yourself, am I right? Or maybe some of you tried to do it together. Robotics track is a very nice place because we have a small amount of people, but we are used to work together. Because we have a lot of hardware tasks, you have to be in groups. You haven't have it now, but on next semester in mechatronics you will have it. On introduction to robotics you have to do some task with manipulator, for instance, and in this case you have to work in a group. So you can start to do it now. I'm not saying that you're complaining because I agree that it's quite tough. You have spent a lot of time. It's a common situation probably the MSIT SE, because when they start to study, about 20% decided to leave this track on the first semester because it's quite tough just to survive. Because when I studied as a master student and they studied together, they told me that they sleep about 4 or 5 hours per day, and they don't visit any sport activities, anything else. They just work hard. They have on the first day they have to read about 100 pages of technical book, and they should answer and explain a lot of stuff on the day after this. So we have smaller the workload in this.
The main problem is not the tasks itself per se, but the workload of the whole block is different from previous year. Because it's like for us now, it's very like crowded.
I understood.
Yeah.
I didn't say that you are wrong that you don't have high workload. I just said that unfortunately we have to pass through all of this.
Yeah, we can have all of the same tasks and we can be motivated to solve them, but without affecting the grades that much. Like
actually, if not mistaken, all of the home tasks is about 10%.
Yeah, but
that's the problem. That
10%. That's not A.
Work or too much stress for only 10%. While we have to prepare more.
8 from 8.
No, it's said like in the.
It was a mistake. 8 from 80.
Okay. It's like on Moodle it's 80, on slides it's 90.
Because it was all slides and I decreased the grade even before.
Okay. And it's still like.
It's like 2 points for each homework, and it's like a lot of work for 2 points. And we have to do it not because only a point, but.
Do you want to rebalance the grade criterion? How? What do you want to change?
I don't want to rebalance the grades, but I want like the tasks not to be mandatory. Like I can solve the task. Until now, I didn't submit, as you know, I didn't submit
yes,
the
I
homework.
Yes, I see Nabil submitted.
Yeah, because we work separately. I tried to solve the tasks without asking her about anything, and I'm still having problems solving them. I contacted Timur to get some help. So the tasks are putting some stress, and solving the tasks takes time, especially
if you're not solving all home tasks. You still can have a possibility to have a grade. Actually, no, because you need to try to do at least 50% of the home tasks. Mm-hmm. But in spite of it, it's only 5%. It's the reason why I put so small, grading on this. Research task, yes, because they are mandatory, they help you to think. About this home task, actually it's the reason why I have a so small percentage. Because if you feel that you cannot do it, you don't have time, of course in this case your grade won't be so, you have, you can receive B grade or C grade even, but in spite of it you can just drop some home tasks. But as you may understand that I try to make all home tasks, the complexity are increasing. So if you did first home task, in this case when you're solving the second home task, you can base your code and your knowledge on the base, on the previous. Because some of you, for instance, Nabil, you didn't do a simulation, as I found on the plots.
So, approximate simulations?
again, do you understand how it works? And can you actually you need to draw a in your case you didn't do it the velocity itself. I mean you need to show the velocity velocity direction.
But actually the directions on the drawing itself, on the problem
It can
itself,
change
but
during the time. Actually, okay guys, I will show you what does it mean simulation. I will open the guide from previous. Yeah, hi, Hassan. So, I will show first and second week. For instance, Yaroslav. Blah blah blah. Some equations. For instance, GeoGebra. Bam. We start. So it's simulation because you can understand what's going on there. And also he provided the plots. On not in the first week, on the next weeks he decided he started to put also plots. For instance, second.
So we have to do
But
this on GeoGebra.
Not only, okay, it's one of the possible ways. Who else? For instance, Nikita Smirnov.
So you're collecting.
Of course, I collect all home tasks because it's quite important. From what again? From previous years, yes.
Okay.
I collect every information what you send. So, for instance, he used, he wrote it in, I don't know, on Python, if I'm not mistaken, he used some library.
For which one is it?
But again,
For which one is it?
so okay, let's read his, let's see.
Streamlink, I guess.
Ah, he put the next, okay, we will open the second. So yes, Henny made it on the first home task. He did plots, but it was nice because he put all legend. It's quite important. All of the stuff, and he provided fully LaTeX equations. You may see. So of course they spent a lot of time on this. Next week, I mean, this week home task. Okay, again, Nikita. He didn't receive the max grade because he didn't show velocity directions. But the fact that he did it, because of course he told me 2 days to understand how to work with this, with the drawing library. Afterwards, of course, he did it much faster. Who else? For instance, Nastya Minakova. Again, for the second task, she just put equations on, as I explained you, just took pictures. So I can take this, draw something, and blah blah blah. So what I expected, for instance, for this week, let's open Danila's home task. I really like some of you made an applet, GeoGebra applet, because when I checked your home task, who did it? I forgot. Not just GeoGebra like this, but applet. Okay. Where's time? So in this case, it disappeared because actually you don't have velocities on this position. It cannot move on this position. So you may see that it's real work, yes. Of course, you spend all the, but as you may read, that they said that after this, they really deeply understand everything. And today's quiz, I show them, and they do it on the fly. So it's the main reason why I gave you like this, and I show that other batch did it.
So like if we will try to fit like this function of time and amount of pain, it will be like decreasing, right?
Again, I didn't get the question.
Короче, если мы примерно пытаемся аппроксиматизировать функцию от времени, которая показывает количество боли в будущем, она будет монотонно убывающей.
Actually, it depends on your. It seems yes, because in the end, in mechanics and machines and so on, they didn't spend so much time in the beginning. I don't think that's very linear. I mean, like a straight line.
There's more pain at the beginning. That's what
Yes.
we need to know. Okay.
Yes,
Okay.
because actually, guys, see, you have kinematics about one. You have one or two home tasks about kinematics. On first home task, you suffer a lot because you need to understand how to do simulations, how to use linear solvers, and blah blah blah. On second, you have to draw directions. Okay, again pain, but at least you know how to do this one and how to derive it using numerical solver. Later, you already know everything. You just need to implement it. Yes, you have new. For instance, today we will learn complex, let's say, complex motion, and you will have home task about it. But again, so it's based on previous. After this, we're going to dynamic or statics, and statics probably you don't need to code anything. Let me see. Yes. On dynamics again, we start to code, but yeah. Okay. So again, except Danila, nobody asked me anything. Okay, you, but you didn't send it to me. You asked.
I'm just like doing my hand, raising my hand.
No, you asked me a question, but you didn't send it to Telegram.
I asked Professor
Maleta, thank you. Okay, so I mean, only two people asked some questions. If you stuck, you can ask me or you, like Timur, because he, as I understood, know one of the best guys there in terms of knowing how to solve the tasks and so on. So you have a lot of people who can be askable by you. So now we are going to the quiz.
Is it?
Can we use your method even if it is not even if it can be calculated by
Again,
last time you said that calculation time doesn't matter.
yes.
I tried your method and it worked for 20 minutes and didn't find the solution.
Are you sure that you did it correctly?
Yes. I will show later.
Okay.
So, are you ready to wait for infinity of time to get the solution?
So calculate the positions or the velocities?
You need only positions. You need to write kinematic for this guy.
Do you have to redraw it?
If I think yes, because it helps you to understand. I mean, to show something. So you need to show the position, so derive the points A, B, C, E, D, F. Only positions. So only kinematics. Actually, it's your home task too. the triangle ABC, you know everything in it.
May I ask, do you think like the O1, O2, and O3 all are fixed?
Yeah, O1, O2, O3, of course, because you may see this, let's say,
Okay, so but
it's a base.
just look at it. I'm not sure. Can it even rotate? Because the O2 and A01 look different length, and I mean, is it even movable? If you try to
Yes.
Yeah.
Down.
Should we find positions in relative coordinate system or in fixed?
What do you mean by relative?
Like for example, for point A, if we put frame in O1
In O1,
and for B
related
for
to O1
O2.
coordinate.
Okay.
Actually, it's enough just to write the, how to say, all equations that you need this system, and show that you have the same amount of equations and same amount of, how to say, variables.
And we describe the AC equals CD as so.
Yes, you can. Actually, it doesn't matter in this case, because you don't need to solve these equations. Bless you. 5 minutes left. Did you finish, Timo? У других просто так не написано, поэтому я неправильно сделал. Easy.
You just do it.
Yes.
Please start the wars.
It's much easier when you have to complete this. It's like full distance.
If you say easy, once nice.
It's very hard. Don't worry.
But it is solvable this way.
Что видишь, как это solvable? Да, я тебе уже вижу. Свэп. Ты на доске также делал.
Да. Kitman and Simple.
Two minutes left. Don't forget to highlight some. Okay, you don't need any highlighting in there. So at least someone solved it. I am glad to see it. Okay, guys, how to solve it? Actually, firstly we can think about a sur and say that if we have a sur, we can drop this part. But we don't think about this, and even without knowing that it's a sur group, we can solve it. So what can we see there? Falling bar. What we know about falling bar? That we can find the point of its intersection of two circles. So we can find A, we can find just yes, yes, 3 multiply 1. Well, cosine, yeah. This is cosine sine, yes. Actually, we have two equations there. So I hope cosine sine and multiply on OA.
O1.
O1. B, it will be intersection of one circle is O2 B, and second one is AB. In this case we don't know B. We know we don't know B, we know other stuff. It will be in this case xb minus xo2 square plus xb minus yb minus o2 and blah 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 equal to o2 b square. The same for ab. Because I mean yes. xb minus xa square blah blah blah. So two equations, two variables. Okay, how can I find c?
Same.
The same. Again, intersection between
Sorry.
yes, two circles, BC and AC, or whatever. Actually, you can choose any because you know everything there. Okay, find C. We can drop this one again. We know that we know this one and this intersection between DO3 and the DC. For A we found D. Again, okay, how to find E?
Point on a section.
Point on the line, yes, we did it. So it will be C plus DC or DC divided by DC. We met with this equation 2 or 3 times because it's unitary vector of direction, it's a magnitude, and this is C because we need to solve it according to from the C basis. Actually, we just make a translation. I explained it to the first year bachelors yesterday. Yes. And the final, we found E, and we need to find F. It will be all for F and F. So two equations, one equation, two equations, two equations, one equation. That's it. 1 minute.
Yeah, when you know solution, it's really fast.
It's enough. So you wrote this, so you solve this task. Because after this, I just need to, these guys you cannot solve it using analytical mainly. It's the reason why you calculate about 20 minutes. You try to solve it analytically, yeah? You need to try to solve it numerically because this kind of task is quite complicated to solve it analytically.
How do you find velocities, etc.?
Also, we don't find them.
In this case, in those, you can take derivative. You cannot take a derivative numerically. I mean, find velocities. And you need to solve and draw the picture.
Okay.
Actually, the reason why students say they either spend a lot of time to derive this or try to understand how to work with numerical solvers. Yes, it's the reason why I told you that in real life, yes, it's a real life task. Try to solve it as you can. I give you, so to sum up, I gave you 20 minutes for the task that can be solved in 1 minute. I'm glad that some of you understood. Please, did you get how we did it? What you didn't get? How to think or what?
I do not think well under stress. I'm sorry.
Okay, I will have to wait. So, actually, we have the same task on the, let's say, on how week 2. Who have tried to do it? So, you know?
What? Sorry.
Did you try to solve that in week 2?
Yes.
So, did you solve this one?
You mean homework too?
No, Daniela solved it, definitely. I saw it when I took your work. No, I mean, did you solve the quiz? Did you solve the quiz?
Me?
Yes. You.
Yes.
So, okay. It will also a check. Did you try to do it at home or not? Okay, complex motion. Actually, it's just extension of our previous tasks. How can you understand? How the Maloletov explain how to solve this task?
Yeah, what's
The question is to find all accelerations and velocities of point S. I mean point M, yes.
What is this?
So you have a Flagstock the flag, and it rotates. You have the point which moves on this flag, and you know the trajectory.
It just rotates around V.
Yes.
And moves down.
Yes. What the algorithm for solving such tasks? What Maloletov explained?
Like find transport and
What
relation
should you find?
components.
I told you accelerations and velocities of M.
So you need to find transport velocity and relative velocity.
I mean, okay, we need to do it, but what engineer? How can we do it?
By using formula.
No, formula. Okay, actually we can write formula, but it won't help you to understand the core idea. So equation is following: A.
You stop the flag.
Like we stop the body or we stop the point.
You stop the flag.
Yeah, exactly.
Then it goes back.
In acceleration we need to find
Right.
Coriolis acceleration.
Actually, yes. Some of you say stop. One body stop another body and solve it. Actually, as I imagine it, that for myself, we have a bus. When I sitting in the bus, it's just translational motion. Even it can not translational, but bus just move. It's not a complex motion. It's bus, but plane motion. So it can rotate, it can move forward. It's okay. When the bus stop, I also can go forward, backward as a point, because actually in the car I can say that I'm kind of a point. I'm going side of this. But when the bus rotates, side to, and I want to go to, for instance, I don't know, to the exit of the bus, you feel that you want to, you feel some acceleration during this. And as I imagine, so firstly, I stop the bus and I work as I just, bus stops and I just move around and I can solve any velocities, accelerations of myself. After this, I just forget that time exists and I work with bus itself. That it rotates, it moves. And after this, I just understood that I have a previous acceleration. That's it.
Question about the task. Is there angular acceleration?
Yeah. No, actually, the task. I will write the task. Wait a moment. We know the E, we know S equal 4 is S tau. Usually in our task we will meet not this kind of, let's say, notation, but a natural form. Just that's it. And S of tau. We have coordinate form, we have radius vector form, yes, and the last one natural form. You know, alpha is this one. Okay, so firstly we need to understand what's going on there. We know that we understood this plane motion because we have, or for not plane motion, we have the, let's say, the transport body, let me say like this, it make a rotational motion. So,
And the point is with the same line.
and relative, it just, yes, it's point more, particle motion. Why do we need it there? Because in this case we know, do we have tangent acceleration or angular velocities and blah blah blah. Because I hope you understood that particle doesn't have angular velocity itself. Because we cannot rotate. So after this, again, what the algorithm, if we know we have S, we understood that we need to work with what? Accelerations. So what can we do?
Take derivative.
Yes, we just took the derivatives of these guys. Why do we need it also? Because we need to draw pictures, we need to understand the directions. So S dot is equal to 12t squared and not S, let's call it M relative, yes. And M relative equal to 24t. So we see that they are both positive. It means that our direction will be there. Let's draw the picture. Listen. Actually, this kind of task, when with complex motion, you have to draw a lot. Because for this case, I draw 3 pictures to understand better what's going on there.
Because the velocities and
No, because we're working in 3D.
Yeah. Oh, so they're going everywhere.
Yes.
Okay. I will.
Fortunately, we have colored markers. So in this case, you can draw Vm relative and yes, we are trying to solve this task. Do you understand from the lecture? Okay, actually we found everything. What can we do from relative part? Now we are going to the transfer part. We know that it makes a rotational motion. What can we do there? Firstly, I will redraw picture in the top view, because in this case I cannot draw the velocities. It's not very easy for us. So, in this case, it will be okay, yes.
So epsilon is 0.
Epsilon, yes. From the top view, it will be S cosine alpha. Did you get why? Because it has this interest from just projection. The top view.
Cosine 90 minus alpha.
Why cosine? Cosine.
Cosine
60. Ah.
Cm is equal to.
На сайте
Okay.
Yes.
Alpha is the 6.
So we know this rotates in this direction, omega e. So in this case, where it will be our linear velocity? There. With m transpose. What about, okay, can we find this? Of course, it will be Can we find this? Yes, because we know omega, we know cosine, and s each time, because we have s equal to t. So, summa we want to find full velocity, because the task we need to find velocity accelerated for the whole point. In velocities we don't have Coriolis. Don't forget about it. Coriolis exists only in accelerations. Probably you remember Coriolis force, and it depends on this, because it's based on mh and a Coriolis. So, okay, forget about what I said before. So, in this case, you look
Are perpendicular.
again. They're perpendicular, yes, but in such manner. So it look in this way. In this case, we just don't need to have cosine sine rule because sine degrees.
Oh, we know both.
Yeah, we know both of them because we found m there and transpose, and there we found the relative.
Okay, we found it.
Yes. So, okay. The final step is find accelerations. Any questions? Mirna. Again, we are working with transport and relative. And relative we found it already. Transport.
There is no tangential because there is no angular force.
Yes, exactly.
But tangential normal is velocity squared over velocity.
Do we have a main? No, because it moves. It doesn't move. This point. It cannot rotate. I mean, zero. We don't, do we have tangent?
No.
No,
Epsilon is 0.
because we don't have acceleration, angular acceleration. And the last guy, so we find normal. Yeah. Thanks. So, and to sum up, we need to find acceleration. Lower is force by acceleration. The problem there that we have again cross product, and we need to not make mistakes there. Let's understood how it's going on. So what the picture will be the best for us. Relative force is there. Acceleration is there.
Both pictures. You need both pictures.
Actually, yes, but I do it.
You can draw separate.
So actually, auxiliary force will be there.
How do we determine the direction of Coriolis?
So we have velocity from transport, angular velocity. This one. It's here. We have relative. It's look there. So from the first to the second, we're going. Boom, boom.
We know both direction and how we derive the direction of Coriolis.
So do you know the direction of angular velocity?
Yep.
So
Do you know the direction of relative
like,
velocity?
it
Yes.
should be opposite. The
It's how we
direction
find
of
the Coriolis.
Coriolis force.
Direction.
Cross product.
The direction of it.
Cross product provide you direction.
Direction of acceleration.
Yes.
And direction of force, it should be opposite.
Force, yes, opposite. But we don't need to know about the Coriolis force. Forget about this.
It's a non-existent force, you don't really need.
We are working in kinematics, no force.
I'm not turning cross force.
So an acceleration.
Do you know
How we draw it on the picture?
We have the M.
Yep.
We have omega.
Yes.
Find the cross product. From omega to this is positive or negative movement? Negative. So it means that we have this direction.
Может он наоборот?
It's from us.
Yeah.
This to this. Против часовой.
Да, типа туда. Есть.
But the answer would be just multiplication. It will be sine between of them. It will be sine 90 plus 60.
Is omega and v are perpendicular to each other? Or they are not?
Again, omega and Vm,
V relative. Yeah.
they are not perpendicular. They have angle there.
So how can we employ the right angle rule in non-perpendicular vectors?
According to the definition of cross product,
You take the plane.
it doesn't matter. It can be. You need to take a plane. So it doesn't matter in which direction. I mean, the angle between all this. So
Yeah. We find the
not
cross
to change.
products.
The direction
By,
will be the same.
by cross product we find a plane, and how do we determine the normal vector of this plane? To which side?
Basically,
You look at it.
Okay, so you go from the first vector to the second vector. In our case, it's from the velocity.
From angular velocity to linear velocity.
Yeah.
Clockwise.
If it's clockwise, it's negative.
What is?
And in this case, it will be in those direction. If it's positive, in this direction.
Yeah. Or you can use right hand rule.
Right hand rule, yes.
Я понял.
So this is
По-другому. Не вот эта тема.
за точку в почку. So in our case it will be square omega on velocity relative blah blah on sine 90 minus alpha. And to sum up, we have three. So we found all three accelerations, Coriolis. Coriolis, relative, and normal. Not transpose in our case.
Почему именно так? Две.
According to the equation, yes.
There should be cross product. How can we? I think I missed this chain when you go from cross product to the dot product.
That's the.
What's the geometrical representation of cross product?
Area.
What?
Area. Площадь.
Yes, but what's the equation? We can write equation, and then when we're talking about cross product, we can write it in geometrical way. It means when A and B on sine alpha. Either it can be, let's say, A hat B. Either it can be determined, I mean not determined by EGK, and you solve it. Yes,
Yes.
just one of the possible solution. Because in this case you can find the magnitude. These two guys give you a magnitude and the direction. So to sum up, we need to summarize again as a vector. So in this case, we receive Coriolis there, relative there, and normal.
Or transport.
It should be
Equal to the whole.
okay. Dirty green, you know. So we are summarizing them and receive the answer to be somewhere there. Is the reason why in this task it's crucial and obligatory for you to draw pictures. Because you may see that we are working in 3D, you need to make a lot of projections to understand what's going on there. Otherwise you can make in cosine sine rules, you cannot understand how to solve the summary of A, and so on.
Unless you're an absolute god.
Any questions regarding to this task? Actually, the algorithm is the same as we did before. We know something, we try to solve. We know this as respect to t, okay, find everything for this. So actually, yeah, I may say that we divide this task on two subtasks. One of them when we are working only with particle motion, another one and when we are working with the body itself. And after this we just say connect it together, and that's it.
And don't forget the real story.
Of course, yes. Don't. I hope you actually you will meet some tricky task when you don't have Coriolis acceleration. Because in some cases velocity won't exist. In some cases, angular velocity won't exist. In some cases, linear velocity yes won't exist. Okay. The last task for today.
Is it possible to solve a problem about spherical motion because we didn't solve any problems last year?
Again, about what? Spherical?
Spherical motion. We have two tasks, but we didn't solve.
Yeah, let's do it on the next class. Again, who tried to do it at home and you can prove it?
We tried.
We tried, but
That I put
it's hard.
the last slide and we have solution. No.
Ну, я пытался.
What was the problem?
Там что-то сложное было. Омега. Я смотрел решение, но решение я тоже не понял.
He didn't get the solution. Did you try to solve this?
yes, we tried.
Did
to
you
look
look at the solution?
Some stuff doesn't make sense. Like we need to understand more.
Okay, let's solve this. I mean, again, together on the next class. Spherical motion. Today we are solving this guy. By the way, did you get the Malaletov tried to explain you the Euler angles and fixed angles? Did you get it? How to use it? Why do we need it?
I saw a lot of formulas.
Okay, because you will have extra material about this. It's very crucial for manipulators, because when you're one with wrists, we have to represent it in spherical motion, because it rotates like this, and we want to grab something and so on. Actually, all manipulators work in Euler angles or fixed angles. It's up to you. So we will have quiz on it. I really recommend you to look this lectures. It's from Stanford University.
Next lab we will have quiz on this, not this material. Because it's not fair to study both of them. To study the one we take to and read from the book and read the slide, read the lab, try to solve them. Try
Euler
to
angles, it's one equation.
Yeah, but
Yeah,
I mean
but
for
many
this,
ideas.
I mean for this one and for the last one, because the quiz for today was about something that we didn't solve in the labs, something we had to study by ourselves. And this
Today's
not-
quiz, no.
Yeah.
It was on big home task and also explain a group too.
No, I
Falling
watched-
bar, did we solve this during the
No,
class?
we didn't solve it.
Guys, did we solve falling bar during the class?
Я помню, что-то стол какой-то был.
Actually, you received extra grade for this.
Yes, plus 1 point.
Yes, you are actually, except Andrei, everybody else, I put it on the previous quiz because you didn't have two, you
what-
have one, and I put it there. Yes. So
we were solving like the.
they solved it on the whiteboard.
Yes, but not the complex one that you put in the last slide. There were three figures, and you write that we should read about them and try to solve them. And today's quiz was one like not the one we solved it is were very simple comparable to this one.
About grade, don't worry again, because
I'm
if
not
you
worrying
do
about
it
that grade.
We
why
need to understand.
about half of the people solve this task.
But this makes us very depressed. Why we should study if I have a quiz on something that I didn't study in the labs, I don't understand by myself. I even study the things that we took hardly. Today we have 4 classes for after this one from
Yeah, I know,
9
yes.
We have four lectures and tomorrow 4 lectures. So I don't have time to study even this topic. So how I study extra topic
Okay,
and
you
have
will
exam,
have only
exam
this on the
this.
quiz.
What?
You will have only this one on the quiz. Don't worry. Only Euler angle. It wasn't a lecture. It's one lecture, 1.5 hours. That's it. Actually, if you open the slides, Malaletov slides, you can prepare for using them. It's just extra material, nothing special.
Можно тут доски сделать?
Хочешь доски?
Ну, нет, я не
There's no
против.
Coriolis force.
Мне кажется, это будет
What again?
There's
понятно.
no Coriolis force.
Force?
There's no Coriolis like acceleration.
Acceleration.
Ah,
Okay.
yes, because velocity.
There are also velocities, you know? If you take the right thing.
Yes, exactly. Zahar, could you explain the whiteboard? Why don't
I
you
don't know how to solve, but I can try.
try? You have 70 minutes to try.
Час.
Окей. Давай черный лучше. Сори,
Плохо с
повторяю.
моторикой. Что ты написал?
And the phone. Guys, I'm ready to make office hours on Wednesday and this time. If you really need it, you can ask me. You can meet. If you have some problems you cannot solve and so on. I'm here not to drop you. I'm here to help you. Yes, I know this is a stress situation. We have to solve a lot of tasks and blah blah blah.
So these office hours are tomorrow or?
It's Wednesday.
Okay.
Third year you don't have any classes according to this.
We have like 4 lectures.
Do you have any classes there?
What? At this time, no, but after
So in
that,
this
yeah.
okay. Why it's equal
We
to
need to
zero?
find the geometry.
Because it's just
You didn't explain why it doesn't have angular.
like rotational motion.
Mhm.
So relatively to the cut,
Yes.
A is just rotating without
Mhm.
translation. So it means that we have a linear velocity of A equals to 0 relative to the cut. And this is
If you take
omega cross velocity.
Actually, no.
you take the
I
body,
disagree.
if you take the motor as the body and not the car.
Yes.
If we take what?
You take the motor as the body and not the car.
Actually, your transport stuff cannot rotate. Your angular velocity of transport will be equal to 0, not linear velocity.
Why?
Your cart cannot rotate.
Okay.
Who is the boss here? Motor or car?
Why not cut? So
Which body are you taking for the pole? And as the body you're going to be running.
Again,
for.
imagine bus and you as a person, a passenger in the car. Probably I can be a transport and the, and the car will be. It's the same. Cart is like a big boss, like bus, and motor itself it's a.
okay.
Because actually there you're working with what? A, what is it? Is it point?
Yes.
Not body. How can you make a transport body or a point?
A is a point.
Yes.
Is a point.
Okay.
Yes, it's a point. A car has an acceleration. Nice. Electric motion rule. Motion rule what? Of this point. We are not interested in full body. We're interested in one point.
Okay.
So in this case, yes, rotational, but it's relative. Actually, it's particle motion, yes, rotational motion in this case. What about cart?
Translation.
And what does it mean for us? Right? Cart. Can we find angular velocity in translational motion?
No, that's
So, according to this, it's for transport, it's for relative.
Looks like
Okay.
more. Not the car.
What again?
Maybe for just
знаете, который, the alarm clock who try to run, when it start to work, is try to run, yes, run away from you. Startup idea, you know.
What we just want to survive.
So what do we know?
We can find only by four.
Eight.
Yes.
Yes.
And acceleration, angular acceleration too. Will we have angular acceleration there?
Yes.
Okay. I already draw it in the picture. We have both of them and the direction itself.
So it is like this.
Yes. Very understandable picture, you know.
Yeah. For me, it's really understandable. So we need to find.
Mirna, can you understand what's going on in this picture?
Cell brain.
Okay, we found this. What can we do?
We need to find a acceleration of a
Yes.
relative to the body and transfer acceleration of a.
Can we think in transport? You have translational motion. What's the equation of translational motion? Again, assume that this point not moved.
Yes. A0.
Everybody agree? Timur, do you agree with that? The translational motion of this guy is A0.
No, it's really no.
What do you think?
I mean, it's 49.3 now.
Yes.
Yeah.
So okay, you found translational
Okay.
acceleration.
Oh, easy.
Now you need to think about relative, yes. Actually, yes, you forget something else. When we have rotational motion, how many accelerations do we have?
One, like, tangent and
Normal.
normal. Значит, плюс Америка, right? Here.
Не в ту сторону. Do you have rotation in such direction? Why you have tangent in opposite direction?
Oh.
Типа сюда ускорение, потом
Просто с минусом.
сюда.
Пишешь минус а там. You have, let's think, we have angular velocity this direction. Angular acceleration this direction. I need to have linear acceleration.
Direction is like this, not clockwise.
It's the
Yo,
same
it's
thing.
a vector. It's a vector.
Yeah.
This is not a vector.
Okay. But I'm trying to use this field
pointing one of the fingers in the wrong direction.
This is our.
This is how it should look like. You have angular acceleration there, radius is there. Tangent goes out.
Джорджа Фаги.
Gang sign.
Окей. Дальше.
Actually, I agree with Молодец. It's easier to use when we have you need to clockwise or counterclockwise according to this point. So, see, we have angular velocity in this direction. We have what else?
Epsilon in this
There.
direction.
So in this case, we want to go from 1 to second. It's positive, no, it's negative. So it means that it will be there. Do you remember the previous task when we draw a cross?
It's easier to use the right hand.
Yeah, that middle was like.
So So we are going from the first to the second. Is it positive? No, it's negative. Because clockwise.
А можно тоже
Правило такие. По факту смотри. По правилу нет, по определению. Если ты идешь от первого вектора ко второму, и у тебя значение получается положительными, значит у тебя оно смотрит, грубо говоря, в эту сторону. А если отрицательное, то с противоположной. У нас отрицательное значение, поскольку туда. От первого ко второму у нас отрицательное значение получается. Потому что, буквально. Поэтому обязательно. Как бы, можешь правила руки оттренировать.
С пальцем.
Андрей, did you understand how to solve this task?
I was lost about half an hour ago because of the headache.
Okay. Bless you, don't die. Probably the evil will go through you or out of you after this. Safe Nabil, did you get how to solve this task? Will you lose the point?
No, I need to practice more on the topic itself.
Did you get why we don't have there the periodic acceleration?
Because the point itself is moving linearly.
Because we don't have on transport part, we don't have angular acceleration because it's translational motion. Actually, is the reason why I asked to write for each body what we are having. I mean, what the kind of motion. Because just writing it correctly, you already know the answer that you don't have
In
acceleration.
this case, talking about
So the final stuff is to find the how to say summary. The sum.
Angular acceleration.
The full acceleration. Because actually it's not so easy there.
Basically, it doesn't work. So there's no like.
Like this.
Like, how could you find this using equations?
Не, я просто направил.
You already have it. So again, let's redraw it in nice manner because we put a little, it's a bit messy. This point. In this point we have tangent there, transport there, normal there. How can we find this? Actually, for solving this task, it's better to divide the basis.
Yeah, just project.
Yes, no. we put it on the basis. I mean, on x-axis and on y-axis. Because in this case, we know the s angle 30 degrees. We already know it there. And in the x-axis, one will disappear. In other case, the other will disappear. And you solve it, and you can solve it. My English is today is quite poor. How did you get now? Okay. Do it again.
Draw a coordinate system.
So you need to draw a coordinate system. Now project everything on them. So you need to write for x-axis and for y-axis all of this stuff. You know it. I'm not sure.
It's the same angle.
Почему?
Math. Come on, you can do it.
Мне плохо с геометрией. Сейчас.
Это 60, это 60.
Это будет 60. Это сейчас. Между значит, это тоже.
Actually, you need to find the, so if you took like this, yes, it's alpha.
Значит, это 60.
Yes. And you just need to write for x and for y-axis. So just sine, cosine rule. Oh, sine, cosine. I see you already there. I will finish. Just cosine sine rule, project and that's it. So on next class we will try to solve the spherical motion and continue to work with complex motion. And probably, if not mistaken, the midterm will be soon.
Next.
I will say, actually, I hope no.
I hope not.
I will just, at least, I will add one for the extra class for preparation probably. Because it seems that you are not so, your knowledge is not so solid and you are weak in some concepts.
We need to solve more homework.
You at least need to solve home task, yes.
More. Clearly, we need more homework. Otherwise,